It's Wednesday, and today we're doing Honors 11-3 Day 1. My hope is to get through 2 pages of notes, and then I will be able to make Friday a catch-up day. Otherwise, if I can only get through this first section, then we'll have 3 days of work. But let's try it. All right, simplifying radical expressions. We've already rationalized things before, I think, but even if we haven't, it's all the same rules. We just now have x's, whereas before we didn't have x's. Okay? So, if you ever have a radical in the denominator, that is a no-go. So all you're going to do is I want to get rid of that radical. So I'm just going to take whatever's in the radical and multiply by that exact same thing. So square root x, square root x. By multiplying by root x of a root x, you're just multiplying by essentially a 1, which means you're not changing anything. You're just changing the way it looks. You're going to multiply straight across top. 1 times root x is just root x. The bottom is 2. And then root x times root x is root x squared. I don't recommend doing this step. I'm just going to show you why this works out though. Because what is the square root of x squared? Well, I've just now created a group of 2 inside of my square root, so the answer is just going to be an x on the inside. Well, on the outside rather. So the square root of x squared is just x. And that will always be the case. If you ever multiply a radical by itself, it just negates that radical and just becomes the inside stuff. And that's it. Rationalizing is just getting rid of that radical. Okay, so here the only issue is the radical in the denominator. I don't care about this root 7, who cares? Just this guy. If you want to reduce it beforehand, you can, but it's just as easy to do it or not do it. So I'm just going to multiply by root 8x to the 5th, multiply by root 8x to the 5th. This does result in bigger numbers up top, but you just pick your battles. So if you want to reduce this first and get 2x squared root 2x, that's fine as well. But I'm just going to multiply straight across the top. 8 times 7, 56. X to the 5th on the inside of that radical. Bottom, I'm not going to actually multiply these out. 8 and 8 are a pair, so they're going to come on the outside. X to the 5th and x to the 5th would be x to the 10th. 2 goes into 10 5 times. It's just going to become whatever's on the inside just goes away. Okay, and then I'm going to reduce this guy. So 56, half of 56 is 28. Half of 28 is 14. Half of 14 is 7. So I do a pair of 2's that can come out. So moving on down here, I can take out a 2, skip some space, leaving 2 and 7 don't have partners. So I'm just going to push them back together and make them a 14. And then don't forget my index is 2. 2 goes into 5 how many times? Or if I'm looking at all these x's, how many pairs of size 2 can I take out? Well, 2 goes into 5 2 whole times with 1 remainder. Okay, and then the denominator didn't change, so 8x to the 5th. And then lastly, just clean this guy up. 2 and 8 reduced to be a 4th. X to the 2nd and x to the 5th, that's bottom heavy, so those are going to go downstairs. You're going to say 5 minus 2, which is 3. And on the denominator, on the numerator, you're just going to have that straight up 14x. All right, so hopefully that's enough examples for you to see I didn't make any more. If you have a radical on the bottom, you just multiply by top and bottom, same thing, and then just take care of the math, however many steps that takes you to do. Okay, so the next we're going to talk about multiplying binomials, and I think one example here is plenty. If you need to watch it again, go for it. But I have 2 binomials. Don't forget, we multiply the first term times the first term. 8 times 8 is 64. We multiply the first term times the last term. And don't forget, when you multiply radicals, you do outside, outside, inside, inside. So 8 is an outside number, and so is negative understood 1. So that product is negative 8. Inside, there's nothing inside here, so I just have it inside root 7. Okay, then you're going to do this term times both of these guys. So a positive root 7 times 8 is a positive 8 root 7. And then multiply these together. This is going to be a positive times a negative, which is a negative. And then root 7 times root 7 is just 7. This is not always the case. I mean, obviously, I chose numbers. You can see that these are the exact same binomials with a plus and a minus. These are actually called conjugates. So I chose this on purpose, but normally you wouldn't have that. So you would just end up with these 4 terms. This last term may or may not work out to be a constant. It might still be a radical. So just be mindful of what you're working on. Okay, but because I have conjugates, the same exact thing with a plus and a minus, this actually results in the exact same thing in the middle with the plus and a minus. So that's actually going to cancel out. So then 64 minus 7 is 57. So this one works out really nice. And that's because I'm getting ready to teach you about conjugates, so I chose this one. But these normally don't work out. They only work out perfectly if they happen to be the exact same thing with a different sign. That's the only time they work out perfect. Otherwise, you get like root 5 plus 8 or something like that, and that's okay. All right, moving on down. These are going to involve a conjugate. So the issue here is that I have this radical on the bottom, and I do not want that radical. But I cannot just multiply by root 5 on top and bottom, because when you multiply by root 5 by this quantity here, you would end up with 2 root 5, and you'd still have a radical on the bottom. So you cannot just multiply by just the radical. If it's a multiplication, sure, like if there's things multiplying together, then you can multiply by just the radical. But if there is any addition or subtraction, as in these guys, you cannot. So you're going to multiply by the conjugate. The conjugate is the exact same thing with a different sign in the middle. Okay, so 2 plus root 5, 2 minus root 5. 2 plus root 5. All right, when multiplying, 1 times 2 is just 2. 1 times positive root 5 is positive root 5. Bottom, 2 times 2 is 4. I'm going to show you this first one all written out, but do the shortcut, and I'll show you that in a second. 2 times positive root 5 is 2 root 5. A negative root 5 times 2 is a negative 2 root 5. And negative root 5 times a positive root 5 is a negative, just straight up 5. Don't forget, those radicals just cancel out that radical and just keep the number. Okay, the numerator is not going to change, so 2 plus root 5. This is always going to cancel out, so it's just 4 minus 5, which is a negative 1. And we don't like writing things with a 1 on the bottom, so I'm just going to divide everything by negative. So negative 2 minus root 5 is that answer. Okay, but from henceforth, we are only going to, I'm only going to multiply the first and the last because I know that the outer inner product will always cancel. So that's kind of the shortcut. All right, so on this one, again, I have a sum or a subtraction member. So I can't just multiply by root 2. So I'm going to multiply by the exact same thing with a different sign in the middle. Okay, so it had a plus, now I'm going to make it a minus. All right, multiplying on top, 2 times root 2 is 2 root 2. 2 times negative 5 is negative 10. On the bottom, root 2 times root 2 is just 2. Root 2 times negative 5 is negative 2 root 5, positive 2 root 5, those are always going to cancel. So I'm just going to multiply the first two terms and the last two terms. Negative 5 times 5 is a negative 25. Okay, let's go ahead and clean it up. This is going to result in the bottom of being a negative 23. And again, we don't really like having negatives in the denominator, so I'm just going to divide everything by a negative. So that's going to be a negative 2 root 2 and a positive 10, all divided by 23. And that's my final answer. Also, don't forget, we did it when we did the quadratic formula and stuff. If all these outside numbers happen to share a common factor, like if they were all even, you would divide them all by 2 or 4 or whatever. But because 23 doesn't share a common factor as negative 2 and 10, I just leave it alone. Okay, then this guy here, you could reduce root 18 if you wanted to, but I just think it's much easier just to leave things alone. I'd rather just reduce at the end. So sometimes it results in double reducing. Okay, root 2 times 1 is just root 2. Root 2 times negative root 18 is going to be a negative root 36. And then again, inner-outer product cancels, so multiply the first terms together and the last terms together. Okay, well, root 36 is 6, and 1 minus 18 is negative 17, and again, we have that issue with that negative sign. So I'm going to divide everything by a negative. So I'm going to get negative root 2 plus 6 over 17. And that is that guy. All right, to save time, I'm just going to go ahead and skip one of these. These are both area problems. One just happens to have a monomial times a binomial. You just distribute, and then you get this. Okay, but the other one, the length, so it says find the area. Area is the length times the width. So I do want to go ahead and make sure we look at this guy. Okay, don't forget 4 times 2 is 8. 4 times negative root 3 outside, inside. Those guys can't go together. Then multiply these next two, outside, inside. And then the last two, same number, different sign, so a negative 3. Okay, these guys have the same index and radicand. I'll go ahead and reduce these as well. So area equals 5. And then negative 4 and a positive 2 is a negative 2 root 3, whatever the unit is, yards squared. So don't forget how easy this can be, even though we didn't actually practice one. All right, we can do this in 5 minutes. That way you guys can have a makeup day on Friday, or if you've been caught up, you have nothing to do on Friday. So awesome. Okay, this last thing is just transformations of the square root function, which is the same exact as anything else we've done. So not a very hard concept. I will do 2 examples and that will be it. Okay, so parent function, square root of x. Here is how the square root of x looks. It's actually half of a parabola. So it's an inverse function. So the parabola will go this way. So he actually has that 1, 3, 5 pattern sideways, which is really, really cool. But either way, you have a calculator, you can graph this guy. That's how he looks. Domain is going to be all real numbers, except everything higher than 0. And then the range is the exact same thing. Y greater than or equal to 0. Those are my curly brackets. They look like 3s, whatever. So domain, everything from here over. Range, everything from here up. So just basically understand that that's the parent function. You will see this again later in algebra 2. But if you know it's the parent function, then you know how things look when you move it around. So this has the exact same formula as we had when we did vertex form for quadratics, absolute value, all that jazz. This A value tells you stretch or shrink and a reflection. This H value is the opposite of how you expect, and it's on the inside. That's left and right. And this K value is how you expect, and it's on the outside. So here we have square root x plus 1. So this plus 1 tells me my entire graph is moving up 1 unit because it's on the outside and not on the inside. So I'm going to go ahead, there's a couple ways to do it. You can actually just graph this and get the ordered pairs, but I'm actually going to go ahead and graph the parent function doing the 1, 3, 5 pattern sideways. So up 3 and then up 1, 2, 3, 4 and over 5. So this is the parent function. This is how it normally looks. But if I'm moving the entire graph up 1, I'm literally just going to take my entire graph and move it up 1. So take this guy, move him up 1, take this guy, move him up 1, take this guy, move him up 1, and this guy, move him up 1. And it is going to go to the right. And then if you want to, you can write those ordered pairs down, 0, 1, 1, 3, 2, oh, we don't do a 2. We do a 4, 3, and then that's all we do. Oh, there's a 9. 9, 4. Okay, sorry, that was a little convoluted, but it's okay. The moral of the story is, if you know the basic parent function and you know what's happening to this graph, you can just literally move it around. So the outside tells me it goes up 1, so move your entire graph up 1. This graph is graphed in pink. Not great, but it's okay. All right, this one is on the inside, so it's actually taking my entire function left 3 units. So parent function, boom, boom, and over 1, 2, 3, and then over 1, 2, 3, 4, 5. Okay, so I want to just take my entire function, move it left 3 units. So take this guy, move left 1, 2, 3. Take this guy, move left 1, 2, 3. Take this guy, move left 1, 2, 3. Also, you could do the 1, 3, 5 pattern sideways as well there. And then take this guy, 1, 2, 3. And there he is. And I'm not going to write the order pairs because you could just obviously look yourself. But basically, I want you to understand and to know that you know what the parent function looks like. It's starting at 0, 0, and it's going this direction. And then these inside and outside numbers move it left and right, up and down. I didn't do a practice one with the stretching or shrinking, which we could easily just have put a value on here. If we put a 2 on there, that would just stretch this whole entire function by a factor of 2. So you're going to make it taller. Remember, stretching makes things taller and skinnier, and shrinking makes them shorter and wider. So I would just stretch this. I would move this, so 1 times 2 is 2, and 2 times 2 is 4, and 3 times 2 is 1, 2, 3, 6. So this would be that same function if I happen to have that 2 attached to it. So multiplying or dividing, I guess you could have a 1/2 dividing by 2. Stretching or shrinking is just going to make that guy taller or more shallow. All right, sweet, we made it. So your homework is on Canvas, so just go ahead and do those practice questions. And then tomorrow, I think I can get through all of tomorrow's notes on tomorrow's video. That way you can have Friday as an off day. So we're almost there. Congrats, guys.